Good morning, friends. Today we are going to discuss the chapter The Data Effect. The chapter begins with the description of an analytical competition. The analytical competition was meant to find out which of the used car is a bad buy. The competition analyzed the car on many factors such as their make, their model, and many other salient features. But one of the interesting insights that was generated was that a car which was orange in color was less likely to be a bad buy or a lemon. The results were conclusive at first as they passed all the mathematical significant tests, but as the data grew, the results tend to become insignificant. This happened because testing many predictors means taking many small risks to be of being fooled by randomness, adding up to one big risk. The next topic discussed in the chapter is the source of data. Most of the potentially useful data that is being utilized in predictive analysis is actually a byproduct of the routine task. An example, the phone call that we make to our friends or our family is the main action, while the byproduct of those phone calls is our phone log or the call logs that is being generated by the telecom companies. These call logs are the main source of data that can be used for its predictive analysis. An interesting thing that can be done by a predictive analysis is generalizing an analytics that can be applied on the whole population. There are many ways of doing this. One of such ways is by using the data available on social media. When people tend to share things about their life on social media, the data can be used in an aggregated way to create a generalized analytics or to find a generalized pattern in the behavior of population that can be applied to all. This population behavior can be regarding many topics such as product, stock market, government, sports, music industry, film industry, etc. As discussed in the previous point, a lot of data is being dumped on this social media platform by the users. This data does not have any monetary value when it is alone. But when all this data is being aggregated and a useful analytics is generated from it, the value of analytics is much more than the single standalone data itself. This is the recycling of the data dump that is being done on the public sharing platforms. With the ample amount of data being produced in our day-to-day life, it is just able to capture the bare essence of human behavior. Data is unable to capture things like human emotions and human behavior. But just like microscope that can be used to zoom in into objects and to study it better, data can actually be used to zoom out and see the bigger picture. When we zoom out and see the whole human population as one, we can generate analytics that can be applied to every population as a whole. Understanding the human behavior from this new zoomed out perspective can help discover new patterns and insights about the human behavior that were previously unknown. All the above points prove the great potential of data. But the most valuable thing that can be done with this data is learn how to predict from this data and generate useful insights that can be used for the betterment of human population as a whole.
Hi, my name is Jayajot Kaur and I will be explaining about the growth of data and its predictive value. As we know, data is growing at an incomprehensible speed. That is an estimated 2.5 quintillion bytes of data per day. Now a quintillion is a 1 with 18 zeros, so you can just imagine the data which is dumped upon us every day. Also, where the growth is so exponential, the storage cost has drastically decreased, which means now we don't have to worry about deleting the data for storage space. Then there comes the predictive value of data. Data is always predictive, and one thing is always related to another, be it the shopping expenditure of a person or job satisfaction of an employee. Change in one parameter leads to change in another. Now, as we all know, PA feeds on behavioral predictors. The building blocks of predictive analysis of data is the predictive variable, which is also called as the independent variable. Now, these variables can be recency, frequency, purchases, your web surfing history, etc. In many areas, it makes sense to begin with the most recently active people, like for a clinical assessment or when doing a marketing advertisement for a particular product. Another such variable is frequency. People who have done something a lot are more likely to do it again. For example, a regular customer in your restaurant is likely to visit the restaurant again than any new customer.
Hello everyone, I'm Meet Kamani and I will be talking about correlation does not apply causation. So, starting with causation is a complex concept where as correlation can be measured in different ways. So, it is difficult to sum up what an individual means by saying two things are correlated or one thing causes another. Allow me to explain you with an example. If we were to understand, is income correlated to health? Depends on population we study. The factors that might be important could be comparing one person of different background and ages. Second would be drawing your data from 2021 or over time since 1990. Availability of data on individuals or population. From the above factors, we can get many different answers. If we agree on specific definition of correlation and analyze 1000 people born in Canada in 1991 and compare their total lifetime income with some index of total lifetime health, we might come across people who made more money, lived longer, were healthier. This brings us to some questions like, does a higher income cause better health? Probably in some ways, like good quality medical care, reduction of disease from eating bad food. Another would be, does better health care cause higher income? Probably in some ways, more years to earn, ability to work. There is no simple answer to what causes what. Cause is overdetermined. Things have many causes. Pragmatically, is changing A an effective way of changing B? Should be our focus of interest rather than does A cause B? If A is correlated with B, it suggests that it might be worth investigating whether changing A is an effective way of changing B. And to conclude, with study of correlation requires observation, the casual investigation requires experiment. Securing sound discoveries. If an individual wants to utilize data-driven decision-making needs to have access to relevant data from different activities, and sometimes big data sets are hard to come by. Even if we have sufficient data, critics argue that even anticipating human behavior, computers and algorithms fail to consider variables from changing weather to moods to relationships that might influence purchasing patterns. If I were to back up with a fact, the financial crisis in the year 2008 and 9 signifies how crucial time consideration is because valid data theory and modules predict the likelihood of mortgage customers repaying loans without considering the possibility that housing prices might drop. What I mean to say here is that time also plays a major role in how well these techniques might produce fruitful end results or flow in vain. A data model can be successful at one point, but human behavior changes timely and therefore the model must be updated to incline with the recent trends.
Hi, myself Ashita. I will be explaining about context-dependent probability, false positives, and vast search. Generally, many decisions in our life rely on how we evaluate potential outcomes and estimate their corresponding probabilities of occurrence. In many choices we face, we are not explicitly given information about potential outcomes and their associated probabilities of occurrence. We rarely experience an event in isolation. The context of our experience, that is, the presence of other events unfolding close in time, plays an important role in probability estimation. By understanding that probability estimation is context dependent, not only demonstrates that it is subjective, but more importantly, that it is relative. And it is another source of bias that could affect people's choice behavior. Now, how about calculating the probabilities of the future events with the help of backwards looking data analysis? The aim here is to achieve predictions for situations and events that are as reliable as possible. If one wants to describe this field of expertise using a concrete question, it is what will probably happen? And the forecast and the probabilities of occurrence we achieve with the predictive analytics are always only orientation values that you can very probably achieve. Can means of course that in the end an upward and downward deviation is always possible. One of the forecasting errors is false positive. By false positive, I mean that you claim that an effect exists when in fact the results could easily have occurred by chance only. The false positive risk is the probability that a significant result is nothing more than a chance. In practice, decisions depend on the relative cost in terms of money, reputation, that result from wrongly claiming a real effect when there is none, and by failing to detect a real effect when there is one. With each iteration, if the test suffers, say, a 1% risk that the data will falsely show a predictive effect just by random chance, the accumulated risk piles up. We will stumble upon a random concern that, considered in isolation, is compelling enough to mislead us. Now, we will move on to vast search. When carrying out data analytics work and we find an interesting effect in the data, we always need to ask the standard statistical question: how likely could this result have occurred by chance? A p-value of less than 0.05 or 0.01 can be useful in testing single ideas in a traditional experimental approach, but can quickly become meaningless in the face of big data, and especially for wide data, where thousands of ideas can be tested at a time. Think about this example. We have a 1 in million chance of winning the lottery, and there are 20 million people playing the lottery. So each person has 1 by 10 million chance of winning the lottery. It is not unlikely that someone will win the lottery. Studying that lucky person who did win the lottery, for example, what they ate for breakfast, what color socks they wear, what their favorite color is, etc., will not increase our chances of winning the lottery in future. If you test thousands of hypotheses against a big data set, it is not unlikely that you will find some that look good, but we need to be careful. If we find one, is it random chance in the data or an important effect? The more variables we have, the easier it becomes to oversearch and identify false patterns among them, called the vast search effect. Predictive analytics tools like target shuffling uses a random sampling method on the data to test what the chances the effect you're seeing could be simply random noise or blind luck, in other words, an accident. Thank you.
Hello everyone, I am Param Garg and I'll be taking on from here. A failsafe for sound results. For wanting conclusive data, we must have longer data. Longer data with more number of rows helps in eliminating inconclusive findings. As if data is vast, findings would need to be conclusive to pass through the filters. Data effect will efficiently work till we can support it with enough training examples. For example, in case of yellow car and the lemon, statisticians and data scientists would have different results if they had data on other factors that might have supported their output, like model of the car, manufacturing year, manufacturing place, etc. Prevalent mistake. It's elusive. It totally relies on the data and fails to consider other outside factors that may have an effect on the results. It's new. Being a newcomer, people are yet to be aware of the data science and its application. Simplicity can deceive. Being a simple nature and not having complex model makes them less likely to be screened for failure. Falsehoods don't look wrong. People many times create casual explanations to discoveries of data science which may be actually false. It's a buzzkill. Strong incentives of predictive analysis, intentionally or unintentionally, lead to neglection and causes a temptation to be less scrutinous. In the big data tsunami, you have got to either sharpen your skills or get out of the water.